So today we'll be looking at binary search and how it works. So basically this is the LeetCode problem 704, which is basically doing the binary search problem. And so let's get started. And this is basically a good problem to understand how binary search works. So I'll walk you through an example and then show you how we carry out binary search in a given array. So let's say we have an array which has the following values. So the values are -1, 0, 3, 5, 9, and 12. So these are the values that we have in an array. Okay, and we are tasked with finding the value 8 and whether or not it exists in this array. If it does, we need to return the index. So let's just write the indices on top. This, I think, kind of really helps later on when trying to explain the code, to explain the problem. Okay, so in binary search problems, we basically it's almost, I'd say, like a two-pointer technique, because we use like a left and a right, like these are pointers. So you can almost think of basically it is an application of two pointers on arrays. So how it works is we initialize the left pointer at the beginning and the right pointer at the very end of the array. So L here means the left pointer, right is the right pointer here. So left and right. So the very first step that you do, so let's just write the steps here, is you find the midpoint. Find midpoint. So how do we find it? So it's pretty simple. So what you basically do is you add the left pointer's value to the right pointer's value, and you do an integer division. So in code it is something like this, right? So what is an integer division? Basically, when you get the decimal points, you discard the decimal points and you just take the quotient. Okay, so in the first step we add the left and right pointer values and divide them by and take the integer division of them. So what should that give us in this case? In this case, the left is 0 and right is 5. So 0 plus 5's integer division would give us 2. So what does it mean? It means that the second index is the midpoint right now. Okay, so next step that we do is we check whether this midpoint's index contains the target value or not. So this is basically, like I already had mentioned, our target was 8, right? And let's kind of give a name to this array. So let's call it nums, right? So nums is the array that we have. We initialized our left and right pointers with the beginning of the array and the end of the array respectively. We did our first step, which was calculating the midpoint. We calculated that, and step 2 is basically checking whether nums of this midpoint is our desired value or not. So nums midpoint, is it equal to target or not? So remember this target that we have, does this hold or not? That is what we want to find. So in this case, let's see what the value is. So the value here is 3, right? So 3 is the value that we have in the index that mid is pointing to, which is 3. So 3 is not equals to 8, right? So we haven't found the value that we are supposed to find. Okay, so what do we now have to do is we need to change our our search space, right? So basically here our search space was between the left pointer and right pointer, and we take the middle value of them. So basically the idea is that the middle point of the two pointers that you have, that is where that is where we search for the value. So as we have not found that value, we will change one of the pointers. So now the natural question that arises is, which pointer should we change, right? Or should we change both of them, or how should we change them, right? Okay, so for that, in order to do that, we have what really helps us in changing that is that see this input array that we are given, it is a sorted array, right? So this is a major requirement for binary search to work. The input array has to be sorted. Now why is that? Let's try to understand. So if the input array is sorted, and now if we have not found the mid our target value at the index that mid is pointing, so now we need to change our pointers, and therefore we now have to check this 3 is it greater than or less than our target value of 8, right? So 3 is less than the target value of 8, right? So since 3 is less than target value, right, and this input array is sorted, so it kind of see if you can really try to understand it in an intuitive way, see this portion is basically irrelevant to us, right? Because we know that the input array is sorted, right? So if the input array is sorted and we haven't found the value at the index where mid is pointing to, which is index 2 and has the value 3. This means that all the values that come before this index 2 would naturally get disqualified because 8 is definitely larger than 3 and would be found anywhere which is after mid, right? Because we already know that mid is not the value that we're looking for. So what we do in the next iteration, or the next iteration, is that we change the left pointer, right? So where does the left pointer reside? So left pointer now will take the value of mid plus 1. So that is where left pointer is going here, and then this becomes our second iteration, right? So the step 3 was basically changing the left or right pointer depending on which one of the values that we find. So it's basically kind of a two steps within this step, right? So kind of sub steps. So if the left point, if the the value that mid is pointing to, let me just use a different color here. So if, right, nums of mid is greater than the let's go with the example that I have, is less than the target, right, is less than the target, what we do is we change the left pointer's value, and the left pointer becomes mid plus 1 and right pointer stays where it is. So else if nums of mid, right, the value that we found and the middle pointer, if it is greater than the target, then what do we do, right? Then we kind of if you can see or if you can try to understand, what we would do is we would change the right pointer's value, right? And where would the right pointer's value be? It would be where the mid is, we kind of reduce subtract it by 1. So why are we doing that? That is because we found a value that is already greater than the target, right? And therefore we need to bring our search space to somewhere to the left part of the array, because remember this input array is sorted, right? So that is why we can change these pointers like this, and this will work. So what happens is now let's go with the second iteration. So mid and the left pointer, this will now change because now that we have changed the merge after step 3, and all of this will go in a loop, and as you will be shown in the code, and then we move on to the first step, right? So what was first step? It was finding the midpoint, right? So what are the midpoints, or what would be the midpoint right now? So the midpoint would be 3, which is the value that which is the index that left pointer is pointing to, plus 5, whereas the right pointer is pointing to. Take the integer division of them by 2, and this brings us to a mid, where the midpoint kind of lies here, right? Okay, so the mid lies here now, and then what was this step 2? Let's go back to our pseudocode. The step 2 was finding whether, so if, right, so if, okay, I should just maintain a specific color, I'm sorry about that. So yeah, I think, oops, sorry, if nums of midpoint is equals to target or not. So what is nums of midpoint right now pointing to? It is pointing to the value of 9. So is 9 equals to 8? No, it is not, right? 9 is not equals to 8. 9 is, in fact, what? It is greater than 8, right? Okay, so since 9 is greater than 8, now how do we change our pointers? So see, as I have mentioned here, what we do is we set the right pointer to be 1 less than what mid currently is. So this means that right is now pointing to the same value that left is pointing to, right? Okay. Right. So now this has to change, and then we move on to the first step again. So the first step was finding the midpoint. So now the midpoint is the left and right both are pointing to 3. So 3 plus 3 both now give you like 3 plus 3. If we can take an integer division, the mid is also the same value, right? It is also pointing to the index 3. So then let's go move on to step 2. What is step 2 is nums of midpoint equals to the target. So what is num of midpoint? Num of midpoint is right now has the value of 5. So is a 5 equals to 8? No, it is not equals to 8. So what is 5? 5 is less than 8, right? So what happens when we have when this condition is true? What we do is we increment the left pointer, and the left pointer has a value which is 1 greater than the mid. So the left pointer is now pointing to the right index 4. It is the left pointer now, so this is pointing here. And then we move, and would we then carry out a calculation for step 1? No, we would not, because the one of the major criteria for running this all the steps would be we do all this until this condition is met. And what is that condition? The condition is that left has to be less than the right pointer. If it is more than the right pointer, less than, I'm sorry, it should be less than equal, because remember it was when it was equal we still did the calculation. So up to the point where left pointer is less than or equal to the right pointer, that is only that is when we carry out these 3 steps. So whenever this condition becomes false, we do not continue the searching anymore, and that means that we have not found the value of 8 in our target target 8 in our array. And so that is basically how binary search works. And now let's dive into the code and see how we can implement this. So now let's code up the solution. So let's just refer to how we how I explained it to you in the explanation. So as I said, we'll have a left pointer and a right pointer. So left is initialized to the beginning of the index, which is 0. Right is initialized to the length of this array, which is nums, in this case -1, right? So I've initialized our left and right pointers. So remember I told in the explanation that all of this will continue until the left pointer is less than or equal to right pointer. So that is our condition for the while loop. The while left is less than or equals to right. I'm sorry about the background noise. So while left, so yeah, while left is less than or equals to right, what do? We first calculate the midpoint, right? How is the midpoint calculated? Remember I said it was the left plus right. You add them and take the integer division of left and right divided by 2, right? Okay, so now we got the midpoint. What was the step 2 now? It was checking is, right? So if nums of midpoints, basically midpoint is the index, but it's not the value that we're looking for. Nums of midpoint is what we are looking for, is equals to the target. Sorry, it's equal to the target. Then what do? We just return the index of that value. So basically it returning the midpoint. However, what is the other case that we don't find them, right? Which is what we showed in the example in my previous in my explanation. Sorry. Here we check that whether nums of mid is greater than target or not, right? So if nums of mid is greater than target, if nums of midpoint is greater than the target, what it means is we have to change our right pointer, right? So left says the same. Why is that? Again, remember nums of midpoint is greater than a target. So it means that we must check somewhere lesser than where mid is currently pointing to in order to find the target, because this is an sorted array. So the right is then now becomes midpoint minus 1, and the other case is if nums of midpoint is less than target. What does that mean? That means that the nums of midpoint is less than target, so we need to move or shift our search space towards the right side of the towards the rightmost part of the array, given it is a sorted array. So what we do, and it is in ascending order, so what we do is we change the left pointer's value and it becomes midpoint plus 1, right? So that is basically the entire code. And if none of this, and let's say if the entire loop ends and then we did not find the value, which was in our example case, then we return -1, because that is what the questions ask us to do. So let's quickly run it and check if it works or not. So yeah, it passed both of the test cases, and if you click submit, it will also submit it will also show you that it works. So that is how we do this binary search problem.